Hi, we're going to look at this 2017 AMC10A problem 24. This is a very good polynomial equations, polynomial functions. So let's see the question first. So for certain real number A, B, and C, the polynomial gx equal to x cubed plus ax squared plus x plus 10 has three distinct roots. And each root of gx is also a root of polynomial fx equal to x power 4 plus x power 3 plus bx squared plus 100x plus c. I think that this is a very good question. So the reason is, even though you learn the algebra 2 question, algebra 2 class, learn a polynomial part at the school, this one still look at very challenging, right? So, but I'm going to give you some hint. The first one is about polynomial function. Polynomial is a function that consists of x in the integer degree from n, from 0 power 0, 1 all the way to n, right? So the an minus 1, a1, a0, etc. That's all the coefficients, right? So here, the first an we call the leading coefficient. The leading coefficient cannot be 0, right? Okay, so this one is what we call is a polynomial function, right? Okay, so their polynomial function have a lot of amazing properties. That's a very important part of algebra 2 lesson, right? And in this part, so we're going to talk about one very important theorem called fundamental theorem of algebra. This is talk about polynomial function. This says for polynomial function, uh, this polynomial function, there exists at least one solutions. This solution can be real or complex, at least one, right? So if we come from here, so actually for this polynomial, this has nth degree, right? So they are actually gonna be, total n zeros, n roots, all we call n roots. This is all come from fundamental theorem of algebra. So let's see, this is a polynomial function, fx equal to x squared minus 4x plus 3, right? This actually is quadratic, the second degree polynomial functions, right? According to the fundamental theorem, there are going to be two roots. So actually we can find out easily. This equal to x minus 3 times x minus 1. The two zeros are 1 and 3, right? So this is some background. Now we look at this one. So for certain real number ABC, the polynomial gx is third degree. So this tells you these has three roots. So we can factorize this actually equal to x minus the first root times x minus the second root times x minus the third root, right? So these roots could be real number, could be complex number, right? So if you go to look at this one, fx, the fourth degree, they're going to have four roots. Okay, so and you can see that the interesting part, the gx have three roots that also exist in here. So that means this is going to be also have these three roots: x minus r1, x minus r2, x minus r3. But of course, it has a distinct one, right? Distinct one, right? So that will be x minus r. We call the r, the fourth one, right? So the difference between the gx and fx is only just this part, right? So we can see here. So fx actually equal to x minus r times gx. Right. So from here, so we're going to do this. right? So fx equal to gx times x minus r. So we put fx here. This is fx. This is gx. Then we times x minus r. So we know how to multiply polynomials, right? So then we expand them. We can have x power 4, x cubed times x power 4. We're going to have x power 3. This can have from x squared times x. That's ax cubed. We have x cubed times negative r, so minus r x cubed, right? Okay, so then you can expand. You're going to get this expression. This is fx. Of course, we have expression here, fx here, right? So we can write this down, x fourth plus x cubed plus bx squared plus 100x plus c. So we can compare. So this leading term, x fourth, x4 is good. So they're same, x cubed. So this has coefficient a minus r. This coefficient is 1. They must match. Both have x power 4, x power 3. So we have the very important finding here, a minus r equal to 1. So continue compare x squares, a coefficient, that's 1 minus ra equal to b, right? So we're going to do the third one, 10 minus r equal to 100. And the last one, negative 10 r equal to c. Right, let's look at this. So we have 4 equations. And how many variables? We have a, r, b, r we already saw it, right? C. There are 4 variables with 4 equations. Most likely we can solve these 4 equations, find all the variables. Once we know the a, b, c, and r, so we can find the question, what is f1, right? They are looking for f1. So we just plug in x equal to 1, then we are done, right? The most important thing is find all the variables here. So look at this. Which one we should go first? Yes, this one, right? Okay, this one can easily tells us r equal to negative 90. So since we know negative 90, so this one tells us c equal to negative 90 times negative 10. C actually is 900, right? Okay, so continue. A, R is here. So R is 90. So we can find A actually equal to, so this minus negative 90, that's plus 90. So then subtract 90 both sides. Then we can have, this is negative 89. So then we can have one more, B, right? So this is 1 minus negative 90 times A. We know A is negative 89 equal to B, right? So then what's that? So this one is minus plus plus, so that's going to be minus positive. So 90 times 89, so we can use 90 times 90, that's 100, but minus 90. So that's going to be 8, 0, 10 equal to B. So then B equal to negative 8009. Okay, put this number here. Negative 8009. All right. Okay, so let's see here. So we're gonna find F1. So we're gonna find, we have B here, we have C here. we already have solve B, we have solve C, we put the fx equal to x fourth plus x cubed plus this is negative 8009 x squared plus 100x plus c. C is 900. Right, so we plug in f1. F1 is when x equal to 1. This is 1 plus negative 8009 and 1 squared plus 100. So this is 900, right? Plus 900. Okay, so then you can see this is 1,000. So this is a positive 1,000. Then we have negative. We have this part is negative 709. So we have positive 1 and positive 1 add this. So we have answer is negative 7007. Okay, that will be our answer. Okay, go check the choices. Negative 7,007. That will be the answer.